Now in this video we want to go over some of these proofs. I gave you this as a slideshow previously, and now we want to just show you how we go about um, setting up and writing the statements and reasons for a proof. Okay, so we take a look at the figure, take a look at the information from the figure. We've got the boxes in here. The boxes in here are also confirmed with the statement out here. Angle BAD is a right angle. It's 90 degrees. The box tells you so. So is angle CAE. Okay? And then we look at what it is that they're asking us to prove. So they're telling us that these two angles are right, and then they're trying to tell us that this angle BAC and this angle DAE are equal. That's what we're asked to prove. Okay? So we're going to outline step by step what we do. Any proof involves a statement column and a reason column. Okay? In this case, we're going to start with the given information. And of course, based on that, we should be able to conclude something. Based on the fact that they're right angles, okay, means that they're each equal to 90. That's by definition of the right angle. Yes? So definition of, definition of complementary angle says that BAC and CAD comprise this right angle. Now you might also see that CAD and DAE will comprise the other right angle. And so that is said right there. Okay? And that again is a definition of complementary angles. Now, if this statement is equal to 90 and this statement is equal to 90, then they're both equal to each other. And that's the substitution property. What is 90? Either this or this sum. Either this summation or this summation. So I'm able to set them equal. Now, okay, I can bring back, okay, and see what we have here. What we have here is a common angle. What's a common angle? Well, CAD is in this summation on the left, and it's also in this summation on the right. So basically, I'm going to do subtraction. Okay, how did I get from this line to this line? I subtracted that same thing off of both sides, the angle CAD, and I was able to get what was asked to be proven. Okay, follow the statements again. Start from the given. From the given, make some conclusion about those. Basically, the right angle is comprised of two angles, so complementary angles enter into the picture. Both with this right angle and with the right angle at CAE. Okay, so complementary, then the two things are summed up to 90, so they're both equal to each other by substitution, and then we subtract out the common angle CAD, and we got what we're after. Okay, so there is a statement which is effectively one that we just proven, which is this theorem. If two angles are complementary to the same or congruent angles, then they are congruent each other. Okay? So basically, BAC was complementary to CAD. EAD was complementary to CAD. So therefore, the two angles were congruent to each other. Two angles are complementary to the same or congruent angles, they are congruent to each other. And now, we're going to use that statement in this proof, okay? Well, we're going to write this as a proof. So, we're given angle 1 is some value in terms of x, angle 3 is some value in terms of x. We're asked to find angle 2. What makes us conclude that angle 1 is equal to angle 3? Well, it's the theorem we just proved, okay? Having that statement then, we can use those values that are given or substitute them in. We can proceed with the work to find the value of x. Having the value of x, okay, we can then find what the measure of angle 1 is. Although what we're after is the measure of angle 2, but we should also realize that 1 and 2 are complementary. That's what's stated here. And on that basis, we have angle 2. So you should be able to state what are the reasons for this. What told us that angle 1 was equal to angle 3 was the theorem that we just proved. And that was what? If two angles are complementary to the same angle, they are congruent to each other. The theorem that we just proved previously, okay? That's theorem 2.5. Two angles complementary to the same angle are congruent to one another. All right, the substitution of the algebraic values in place, okay? Actually, in this case, what we did was both addition and subtraction. Of course, we added the 32 to both sides to get the 48, and we subtracted the 2x from them. So I did actually two steps in one line there. Next, of course, is division. Now, I back substituted that value of 16 into angle 1, allowing me to find the angle in degrees, which is 48. And then concluded that 1 and 2 were complementary, all right, and subtracted the 48 from the 90 to reveal 42. So my reasons, that's the substitution back in there. This should be what our definition of complementary angles, and then our subtraction property, okay? If I wanted to, I could have substituted the value of 16 back into angle 3 value, okay, and the result would have been the same, okay? I would have found angle 3, after which I could have found, okay, angle 2. Let's look at this proof. Here, I've given you all the reasons and ask you, this is jumping ahead a little bit, sorry about that. Didn't want you to see those. So let's give you all the reasons. And I'm asking you to find the measure of angle 4. So what are supplements? Well, look at what we've gotten. 1 and 3. 1 and 3 are supplementary. And they're both given. You might say, well, 1 and 2 are supplementary too. 2 and 4 are supplementary, and 3 and 4 are supplementary. But look what the angles they gave you are. 1 and 3. And look what the next step is, substitution. So we're going to start with angles 1 and 3. Then we're going to plug in their values, or substitute those in, right? We're going to simplify, which, as you should be able to determine, is going to give us 8x plus 20. We're going to subtract the 20 from both sides. 8x equals 160. Going to divide. X equals 20. Now, what were we after? We're after angle 4. What did I state down here? Said I'm going to use the vertical angles. What angle is vertical to 4? Well, angle 1 is vertical to 4. Angle 3 and 2 are vertical, but look what we're after. We're after angle 4. So since I've suggested we're going to use vertical angles, and since we're after angle 4, it makes sense that we're going to say angle 1 and angle 4 are vertical. Okay? Now, what's the substitution? Well, the substitution is we've got the value of x, right? We've got the value of x, then basically we have the value of angle 1 and the value of angle 3. But because we started with this statement, 1 and 4 are equal, it makes sense that we're going to find angle 1. Angle 1 is 1/12. Now, look at the next thing it says, transitive property. Okay, the measure of angle 4 is 112. How did we get that? Well, okay, sorry, transitive property, okay, if angle 1 is to 112, which we've established, and angle 1 is equal to angle 4. By transitive property, angle 4 is equal to 112. Again, angle 1 is 112. Angle 1 is equal to angle 4. Therefore, angle 4 is equal to 112. Let's do another one. Okay, here we'll give you 3 angles. We say there's 2 pairs of supplementaries, ABC and DEF, along with supplementaries GHI and DEF. All right, we've got 2 pairs of supplementaries, which you know should comprise a sum of 180 degrees. And we're trying to show, okay, that angle ABC and GHI are equal. So we've got 2 supplements, and we're trying to conclude 2 congruent. We're going to ask you to come up with the statements and the reasons for this. Or each given statement is going to make a conclusion from that. If we said A, B, C, and D, E, F are supplementary, well, it's obvious that's given, so the reason is given. The conclusion of the fact that they're supplementary should imply that their sum is 180, as it is. And reason, definition, supplementary angles. Next, we'll use this other given statement, that these 2 angles are supplementary. Just bring it right back down. That's a given statement. What concludes from that? Well, obviously what concludes from that is their sum is equal to 180, which again is definition of supplementary angles. Now, what are we after? Well, we're after trying to show that ABC, this angle on the left and this angle on the right, GHI, are congruent. What do we know? Well, we know we get 180 adding these up. We know we get 180 adding these up. So they are both equal to each other, since they're both equal to 180. So there we go, okay? If ABC is 180 and GHI and DEF are 180, then they are congruent to each other. That's a substitution, okay? Some might say it's a transitive. I won't argue with that, because if this cluster is 180 and this cluster is 180, then they're both equal to 180. Then they're both equal to each other. Now look at what you got in here. You got DEF on both sides. You can subtract right out. And what's left? That which you were asked to prove. But what's the reason? What got you from here to here? You subtracted the same thing off of both sides. So subtraction property. And we proved another very important theorem, Theorem 2.2. 2 angles are supplementary to the same or congruent angles, then they are congruent to each other. If 2 angles are supplementary to the same or congruent angles, then they are congruent to each other. So now that we've established that as a theorem, and a theorem is something that we can prove, and we need to prove, and then these theorems can be used with other proofs that we have. We're going to stop it there. I suggest you go back, review it. I suggest you try to design these proofs for yourself from the beginning. In other words, suggestion here is that you go back and say you went back to just this statement right here. Go back to just that and then try to work out the proof, the details of it on your own. Because invariably that's what you're going to have to do very shortly. Okay? We'll look at some of these type problems, the proofs, outlining both statements and reasons in class tomorrow.